Okay. A hollow hemispherical porcelain bowl shown in figure 2 has inner radius R1 and an outer radius R2, initially at a room temperature of 25 degrees Celsius. So this initial temperature, yeah, it says initially. So this is my TI, okay? T initial, okay, the initial temperature. The bowl is submerged in the hot water maintained at 90 degrees Celsius. Okay, so this is hot water maintained at 90 degrees Celsius. This should be our ambient temperature because the hot water is a fluid temperature, right? So this refers to T infinity. The convective heat transfer coefficient between the bowl and the water is 10. So this is our H. How long does it take for the bowl to heat up to 60 degrees Celsius? And then we have a second part question here. So let's take this to be question 2a part 1. Okay, and the other question will be 2a part 2. So how long? They ask for how long. So they're asking for the time. When you know time is involved, you know that this should be a transient problem. Okay, a transient problem. Transient problem means the temperature profile changes with time. Okay, temperature changes with time. And immediately, when you know this is a transient problem, within the scope of our syllabus, we will be dealing with lump capacitance problem. Okay, so this is a lump capacitance problem. Okay, so I already done this question before in my previous video, but the reason why I'm creating this is because some people have raised that I've made a calculation error. Okay, so actually it's not so different. But yeah. Okay, I'm just gonna go on and redo this question. So whenever you're dealing with long capacitance problem, first thing first is you don't hop in and straight away use the formulas. First, you check whether long capacitance is applicable. So the way to check it is you calculate the Biot number. So the Biot number is given by the formula H LC over K. LC is referred to as the characteristic length, which is defined by the formula V over A. A is the surface area through which convection occurs. V is the volume of the object. Okay, so finding this is a very simple geometry problem. Okay, so let's see how do you do this. So I understand that some of you might be troubled by geometry, so let's have a look at how we can go about doing this. So first, let's find the volume. So we're given a hemispherical bowl, right? Given here in this figure. How would we calculate the volume of this bowl? So first thing is, I'm going to start with a sphere with radius R2. So this radius is R2. And what I'm going to do is, I'm going to scoop out, okay, wait. I'm going to scoop out another smaller sphere of radius R1 inside of it. Okay, this is a radius of R1. Okay, and to achieve the hemispherical bowl, what you need to do is you need to slice this bowl in half. Okay, slice it in half and get rid of the top. Okay, throw it away. Okay, then what you're left with will be the bowl. This one, which refers to the shape in figure 2. Okay, so when you have this process in mind, you will be able to suss out the formula, the expression for the volume of this hemispherical bowl. So remember, I started out with a sphere of radius R2. Okay, so for the volume of a sphere, the formula is given by 4 over 3 pi r cubed, right? And what did I do next? The next thing I did is I cut out a smaller sphere inside of radius R1. So when you cut it, you are subtracting away, right? So you subtract away minus 4 over 3 pi r1 cubed, right? And the way to simplify this is you notice that they have a common factor of 4 over 3 pi, 4 over 3 pi. So go ahead and factorize that out. So when you factorize that, what you're left with is this. Okay, just makes it simpler. Okay, and that's not it. What else do you need to do? Remember, I said you slice it in half. Okay, you slice it in half. That means you just multiply it by half. Okay, then you substitute in the numbers. Okay, make sure everything is in meters. Okay, because meters is SI units. Yeah. Okay. And the error that I made last time is I didn't multiply by half in my calculator. Okay. I didn't multiply by half in my calculator. So what you should get is 0.000191 meters cubed. And the surface area. So let's check how do you get the surface area. So pay attention to this bowl in figure 2. What are the surfaces exposed to the water? Okay, first thing is we have this outer hemisphere. Okay, the next thing is we have this inner hemisphere. Okay, and the last thing we have is the rim of the bowl. Okay, the rim of the bowl. Okay, so we have 3 parts to the surface area: the outer hemisphere, the inner hemisphere, and then the rim of the bowl. Okay, the rim of the bowl. So let's first tackle with the outer hemisphere. The outer hemisphere, okay, is half the surface area of a sphere, right? Initially, it is one giant sphere, which we know is 4 pi r squared. Okay, 4 pi r squared. But if you only want half of it, we just multiply it by half. Okay, so let's go ahead and do that. So the first one is given, the first hemisphere is given by half of 4 pi r squared. Then the second half, okay, I mean the inner hemisphere, again, it is one entire sphere, but cut into half. So you take, again, the same thing. Half times 4 pi r1 squared. And then the rim, okay, so how do we find the area of the rim? The rim is actually given by a circle with a smaller circle cut out. Okay, so this is radius r1, the outer radius is r2. So we know that the area of a circle is pi r squared, right? So we're given the difference of 2 circles, right? We want to find this area, which is given by the difference of 2 circles. So it'll be pi r2 squared minus pi r1 squared, or simply we can write pi r2 squared minus r1 squared. Okay. So we put this in, pi r2 squared minus r1 squared. Okay. And you substitute in the numbers and then you should get 0.04178 meters squared. Okay, finally you can calculate the characteristic length. So you sub in these two answers, you get 0.04191, 0.04178, and round this off to 0.004561. Okay, finally you can put this into your Biot number formula. So this will be okay, your Biot number is 0.0304. Okay, so pay attention to your Biot number. Your Biot number is 0.0304, etc. So the question is the Biot number less than 0.1? Yes, okay, this number is less than 0.1, meaning to say that lumped capacitance or lumped system analysis is applicable. Meaning to say the formulas that you use, they'll be reasonably accurate. Okay, so let's use the formulas. But what do we asked to find again? We are asked how long does it take for the bowl to heat up to 60 degrees Celsius? In other words, the question asks, find T such that temperature at T is equal to 60 degrees Celsius. Okay, so once we have this down, it's clear what formulas do we need. So we need the time formula. So the time is given by rho VC over HA ln theta I ln theta. Okay, theta I is defined to be Ti minus T infinity, and theta is given by T of T minus T infinity. Okay, actually, the theta at the denominator here is a function of time. So actually, there's an invisible time here. So notice this quantity V over A. What does this look like? This actually refers to the characteristic length. So instead of writing rho VC over HA, this can be effectively transformed into, okay, this is the characteristic length. So this could be rho LC C divided by H. Okay, we do not need to separately substitute volume and area. Otherwise, there'll be a lot to write. Okay, so substitute all in the values. You should get 2300 times 0.004561 times 1085 divided by 10 ln 25 minus 90 divided by 60 minus 90. Okay, punch in your calculator. You should get 880.12 seconds. If you want to, you don't have to. You can change it to minutes divided by 60. Then equivalently, this will be 14.7 minutes. Okay, now let's go to the second part of the problem. The second part of the problem says that if the bowl is then taken out of the hot water to dry in ambient air, 25 degrees Celsius with convective heat transfer coefficient of this. So our H has changed. Initially it was 10, right? But now it has become 25. How long will it take to cool to 35 degrees Celsius? Okay, so what's the second question asking? The second question is asking find T such that temperature at T is equal to 35 degrees Celsius. So, yeah. So let me draw the whole storyline of this problem. So initially, right? Initially, we have a bowl at 25 degrees Celsius. Okay, and then we dump it into hot water of 90 degrees Celsius. Okay, so we dump it in here. The bowl is inside. And then we're asked to find how long does it take for it to heat up to 60 degrees Celsius. Okay, so it heats up to 60 degrees Celsius. Then after that, in the second part of this question, we take out this bowl, and the bowl is left to dry in the room temperature. So the room temperature is 25 degrees Celsius. This is our ambient temperature, T infinity. It now initially starts at 60 degrees Celsius because remember, we heat it up in the heated water until it reaches 60 degrees Celsius, take it out into the room temperature air, which is 25 degrees Celsius. Okay, so if I graph out this problem of temperature against time, it should look like this. Initially, 25 degrees Celsius. Then heats up to 60 degrees Celsius. So we already found this time, right? This is temperature, this is time. We already found this time. Okay, so this time, yeah, okay. Then after that, after it's taken out, it starts from 60 degrees Celsius and cools down until it reaches 35 degrees Celsius. Okay, until it cools down to 35 degrees Celsius. And now we're asked to find this new time. Okay, so this time duration is 2a part 1. This time duration is 2a part 2. Okay, so yeah, we're asked to find this time duration. So we have to update our values. You see, now at this section, right, it starts at 60 degrees Celsius. So Ti is now 60 degrees Celsius. Then T of T, they ask for 35 degrees Celsius. Okay, how long does it take until it reaches 35 degrees Celsius? And H is now updated to 25. Yeah, okay. So before we go and start, before we apply the formula for time, we still need to check the Biot number because the Biot number has changed. Why? Because take a look. The formula for Biot number is HLC over K. LC did not change, right? Remember the formula for LC is V over A. The volume didn't change. The volume of the bowl didn't change. It didn't enlarge and it didn't shrink. Area also didn't change because it didn't enlarge or it didn't shrink. So V over A is the same, meaning you say LC is the same. K is the same because the bowl is still made out of porcelain. So the material didn't change, therefore K didn't change. But H has changed. It's now 25, right? So we need to find the new Biot number, 25 times LC, which is 0.00561 divided by 1.5. So the Biot number is now 0.0760. Ask yourself, is this less than 0.1? Yes, it's less than 0.1. So again, lumped capacitance is applicable. Yeah, so we can continue to use the time formula. So time is given by rho v c over ha times ln theta I divided by theta of t, right? So again, this is your characteristic length. Yeah. Okay, you will get 570.4 seconds. You can change it to minutes, which will become 9.5 minutes. Well, let me check if my answer is correct. Sure, I didn't do any calculation errors. Yeah, okay, should be correct. Yeah. Okay, I just want to do some minor correction with the numbers from the last video. Yeah. So if you found this video helpful, uh, please donate to my Paylah. I'm a bit sick, but in spite of which, I still do this video because I know your finals is urgently coming. Please donate to me so I can buy some medicine. Thank you.